So today we'll be working on Taylor Polynomial and Taylor series or Maclaurin series. And one of the important aspect of Taylor Polynomial is that, or Taylor series is this, that sometimes, we have dealt with exponential function, we have dealt with logarithmic function, we have dealt with trigonometric function, right? So sometimes dealing with these functions are a little bit complicated, a little bit difficult, but with the help of Taylor polynomial or Taylor series, what we can do is we can change these functions, okay? We can change exponential function into polynomial. So for example, I can write that e to the x equals, we will prove it later. So e to the x is clearly an exponential function, but I can write this as 1 plus x squared over factorial 2 plus x cubed over factorial 3 plus it goes like this. And that's the beauty of Taylor polynomial or Taylor series. So we can change exponential function into polynomial function. In the same manner, we can change logarithmic function. For example, let's say if I'm given, let's say ln 1 plus x, for example, okay, then I can change this logarithmic function into polynomial function. We'll prove it later, which will be equal to x minus x squared over 2 plus x cubed over 3 minus x power 4 over 4, and it goes like that. We can change the logarithmic function into polynomial, and these polynomial functions are very familiar to you because you have been dealing with polynomial functions right from your elementary school, your middle school, and you did a lot in your high school as well. So now we can change these functions into polynomial, which you are very comfortable with. Okay, that's what we're going to do. In the same way, if I want to change this trigonometric function, let's say sine x, and sine x will be equal to basically x minus x cubed plus 6, and it goes like that. And we'll see that later, okay? So although exponential and logarithmic functions are quite different from polynomial, they can be closely approximated by polynomials. These approximating polynomials are called Taylor polynomials, after the British mathematician named Brook Taylor, who published his work on them in 1715, long time ago. So here is the learning objective. By the end of today's class, you'll be able to describe the procedure for finding a Taylor polynomial and use the Taylor polynomial to calculate specific functional values. And we have another goal, which is find the Taylor or Maclaurin series expansion for a function. So we have two goals for today's class, okay? It may look a little bit weird for you when when you see this formula. And here is the formula. Here is the Taylor polynomial of degree n at x equal to 0. I want you to memorize this formula just in case if you forget. It will be provided in the exam, but in the future, if you memorize, that's great. So the Taylor polynomial, the definition is here. The formula is here. Let f of x be a function that can be differentiated n times at 0. The nth Taylor polynomial of f of x at x equal to 0 is given by this p of nx. This is the representation for polynomial of degree n, okay? Polynomial of degree n. First of all, I trust that everybody know what is polynomial, okay? So polynomial means, let's say polynomial of degree 2. Okay, that means you have 1 plus, or you can write a naught plus a1x plus a2x squared. So this is the polynomial of degree 2 because the highest power of x is 2. And all these a0, a1, a2 are just numbers. So one simple example of this is, let's say 1 plus 2x, okay, plus x squared, for example. So this is a polynomial of degree 2. So if you want to write polynomial of degree 3, that's going to be, it could be, the first one is just the number plus a1x plus a2x squared plus a3x cubed. So this is called polynomial of degree 3. So you can think of this as, 1 plus, let's say 4x minus 6x squared plus x cubed, for example. So this is one example of polynomial of degree 3. So I trust that everybody know that. Now, polynomial of degree n means the Taylor polynomial is this, given by this formula, f of 0 plus f prime of 0 over factorial 1 x plus f second derivative of 0 over factorial 2 x squared plus it goes all the way up to xn. Now, I trust that you know what is the meaning of factorial. Okay, so the factorial means, if I say factorial 4, can you tell me what is this? It means 4 times 3 times 2 times 1, right? If I write factorial 3, can you tell me what is that? 3 times 2 times 1. Now, in the same way, can you tell me what is factorial negative 4 negative 3, for example? Or negative 4, for example, for that matter. What is the factorial of 1? What is the factorial of 1? What is the factorial of 0? What is the factorial of negative 3? What is the factorial of negative 4? Think about this. Factorial 1. Okay, that is 1. All right, Kuldeep, thank you. Factorial 0. Recall from your high school. Okay, factorial 0 is also 1. What is factorial negative 3 then? So factorial 0 is 1, but factorial of negative number is undefined. Okay, keep that in mind. Factorial of negative number does not exist. They are undefined. All right, so this is quick review from high school. Let's go back to the concept that we are supposed to learn today. Okay, here is the formula. Now, here is, let's look at one example. Find the first 3 Taylor polynomial at x equal to 0 for the function f of x equals sine x. Now remember, here is the Taylor polynomial. So what we need is, we need to find values of all of, this f of 0, f prime of 0, and f double prime of 0, and so on. So first of all, let me just copy that given our function f of x is sine x given. Okay, what we need to do is we need to find a derivative of them, derivative of this function, f prime of x, which is cosine x minus sine x minus cos x. Because we want to find polynomial, the first three Taylor polynomial. So I just want to find just, up to third derivative. Okay, because of this word, first three, that's what we want to find. Now we need to find what is the value of f of 0. And we need to find what is the value of f prime of 0, f second derivative of 0, f third derivative of 0. I can write. So f of 0 is sine 0, which is 0. F prime of 0 is cosine 0, which is 1. F second order derivative of 0, which is negative sine 0, that means 0. And the third derivative is negative cos 0, which is negative 1. Okay? And if you want, you can find the other values as well. Okay? You can find this fourth derivative if you like in the same manner. So that's going to be sine x and so on. But I think because it says only first three, find the first three Taylor polynomial at x equal to 0, I think we'll be fine up to that value here. All right. Now let us copy the formula. Taylor polynomial of degree n is given by the formula Pn of x equals f of 0 plus f prime of 0 over factorial 1 plus, x. I'm just copying the formula as it is. That is the formula. Now we need to find first three Taylor polynomial. Okay, let's look at that. First Taylor polynomial, which means n equals 1. That's going to give me P1. The first Taylor polynomial is P1 of x, that is f of 0 plus f prime of 0 over factorial 1, x. Okay, so the power x, so that means first degree polynomial. First degree polynomial is you just go up to x power 1. Now substitute the value. If you substitute the value, f of 0 we already know, which is 0, plus f prime of 0 is 1 over factorial 1 x. How much is that? It is simply x, right? Now let us find Taylor polynomial, second Taylor polynomial, which means n equals 2. So that means we want to find this. So that means, up to, we'll write the formula up to x squared. So the second degree polynomial is f of 0 plus f prime of 0 over factorial 1 x plus f double prime of 0 over factorial 2 x squared. Because we are writing the second degree polynomial, and you just stop there because that is the second degree, x power is 2. Now substitute the value. F of 0 we already know, which is 0. and f prime of 0 over factorial 1, f prime of 0 is actually 1 over factorial 1 x plus f double prime of 0 is 0 over factorial 2 x squared. So what do you get? Again, simply x. Right? Now let's look at third degree polynomial. Third Taylor polynomial, which is n equals to 3. That means P3 of x is going to be up to x power 3. So that's it. Now you just substitute the value. The first one, f of 0 is 0, plus f prime of 0 is 1 over factorial 1 x, plus the second, the f double prime of 0 is 0 over factorial 2 x squared, plus f third derivative. So the third derivative is negative 1 over factorial 3 x cubed. So if you simplify, you're going to get x minus x cubed over 6, okay? Because factorial 3 is 6. We know that 3 times 2 times 1, which is 6. So we know this. Therefore, this is our third degree polynomial. Any question? Okay, so the main concept that we'll be doing today is this. If you understand this, that means you'll be able to handle pretty much all the other examples and exercise that we'll be doing today. But if you have any question, please let me know. And if you don't have any question, then we'll try a few more questions just for fun, okay? Let's look at example 2. Find the Taylor polynomial of degree 4 at x equal to 0 for the function f of x equals e to the x, and use this result to approximate e raised to power negative 0.07 to 4 decimal places. All right. So are you ready, guys? Now let's calculate. We need to do up to degree 4. So we need to find fourth derivative, up to fourth derivative, okay? So given f of x equals e to the x. Now I want you to find the first derivative, second derivative, third derivative, and fourth derivative. And this is pretty easy, right? So you find e to the x, e to the x, e to the x, e to the x. Now we need to find f of 0, f prime of 0, so f of 0 is e to the 0, which is 1. This is again e to the 0, which is 1. Oh, that's pretty simple, right? So it's all 1. Okay. So let us write the Taylor polynomial of degree 4. So let me just copy the formula. Again, if you memorize this formula, great. If not, then it will be given to you in the exam, by the way. Taylor polynomial of degree 4 is P for x Okay, I write 4, okay, because actually, P n x, that's nth degree. So because we want only 4, I just want to write up to 4 only, if that is okay with you. Now, the first one is f of 0 plus f prime of 0 over factorial 1 x plus okay, this is the 4th degree polynomial. So stop there. Now substitute the value. That's all you need to do. Substituting values. Remember in the earlier example, I did first term, second term, third term, but because you already know how to find all of those terms, so what I'm going to do is I just want to find the 4th degree polynomial, okay? It doesn't say find those 4th, polynomial, each of them separately. It doesn't say that in this question. So we just want to find one polynomial of degree 4. So substituting the value, your 4th degree polynomial will be f of 0 is 1 plus 1 over factorial 1 x plus 1 over factorial 2 x squared plus 1 over factorial 3 x cubed plus 1 over factorial 4 x power 4. That's it. If you think it looks a little ugly, then you can write this way: 1 plus x over factorial 1 plus x squared over factorial 2 x cubed over factorial 3 plus x power 4 over factorial 4. So the first part is done. Maybe I need more space here. So what I'm going to do is I will okay, there we go. So that's the 4th degree polynomial. Now are we done? No, not yet. What it says is that and use this result to approximate e raised to power negative 0.07. Okay, we need to find that value, okay? So to find the approximate value of e to the negative 0.07. So what you do is set e to the negative 0.07 equals ex, because that is the function given, right? The function that we started with is e to the x. So you set them equal and you calculate what is the value of x. Clearly, x is negative 0.07. Okay, because we want to find the value of e to the negative 0.0x07, which means x equals this. Now you just substitute the value of x in that equation. Let me write this equation 1. Okay, this is my equation 1, let's say. Now substitute the value in equation 1. In equation 1, so what you get is p to the power 4, x means negative 0.07, equals 1 plus x means negative 0.07 over factorial 1. Factorial 1 is actually 1. I'll write just 1, okay? Because factorial 1 is 1. X we already wrote. Now the third term is x squared, means negative 0.07 squared, over factorial 2 means 2 times 1, which is 2, plus negative 0.07 power 3 over factorial 3 means 6, plus negative 0.07 power 4. 4 times 3 is 12, 24. Now please use your calculator and let me know what you get. My calculator tells me that this is approximately 0.9323938338. So that's my calculator value. But the question tells us to approximate the value to 4 decimal places. So that means my answer will be 0.9324. Okay, that's what we got. What it means is e raised to power negative 0.07. By using this polynomial, we change that e to the x, okay, we change this e to the x into that polynomial and we substitute the value. That's what we got. Now we want to check whether this value is actually true. Is it approximately correct? So what we do is, let us use the calculator directly. We want to, we want to check our answer is correct. We want to check that, the exponential function, we convert it into polynomial function. Actually, they are approximately equal. We want to check that, okay? So using calculator directly, e to the negative 0.07. And please help me. What is your calculator giving you here? Okay, let me use my calculator. My calculator is giving me 0.9324. When I round it up to 4 decimal places, that's what I got. To 4 decimal. 4 digit after decimal. And let's check whether they are approximately equal. This is what we got using the polynomial, and this is what we got using the calculator directly. Are they equal? Oh, they are pretty equal, right? As a matter of fact, to 4 decimals, they are actually equal. So that's the beauty of Taylor polynomial, guys. So we can change exponential function into polynomial function. So from now onwards, we can use proved from this. So e to the x equals 1 plus x over factorial 1 plus x squared over factorial 2, x cubed over factorial 3, and so on. Okay, guys, in the previous example, in both example, what we consider is we consider Taylor polynomial of degree n at x equal to 0. Okay, that's what we consider in the previous example. But if x is not equal to 0, but something else, let's say x equals to 2, or x equals to 1.5, or x equals to minus 10.7, for example, how do we find the Taylor polynomial, right? Because in the real world situation, then just the specific value of x equal to 0 sometimes doesn't work. So we need to know what happens when the, x is not 0 but something else. So that's what we're going to do. We call it general, the Taylor polynomial of degree n at x equals to a. Okay, it's general Taylor polynomial. So let f of x be a function that can be differentiated n times at x equal to 0. The nth Taylor polynomial of f of x at x equals to a is given by, instead of 0, what we're going to do is we just plug in a there. So f of a plus f prime of a over factorial 1 x minus a, f second derivative of a over factorial 2 x minus a square, and it goes like that. Now let's look at example 3. Find the Taylor polynomial of degree 2 at x equals to 9 for the function f of x equals square root x, and use this result to approximate 9.3, square root of 9.3. All right. So now, okay, what is given here is f of x is given to be square root of x. Degree 2, so we want to find up to second derivative. Guys, can you find it out for me? So the first one will be 1 over 2 square root x. The second one will be negative 1 over 4. Okay, so the function f of x is, x to the power half. The derivative will be 1 over 2 x to the power negative half. The second derivative will be negative 1 over 4 x to the power negative 3 over 2. Now we need to find what is f of 0, f prime of 0, and let us calculate all of these. Oh, not 0. Sorry,
It's
guys.
9.
Here, x equals 9 given. Not 0. It's 9. Okay. Given x equals to 9. So we need to figure out what is f of 9, f prime of 9, f second derivative of 9. So that's going to give me 3. And f prime of 9 is, I believe it's 1 over 6. And this one will be negative 1 over, okay, my calculator gives me 108, but I want to verify this answer with you guys. Did you get the same thing?
Yes, I get the same.
Okay, great, thank you. It's not a big deal, right? It's just you have a calculator, use the calculator. That's what we got. Now, let us write down the Taylor polynomial of degree 2. So Taylor polynomial of degree 2 at a or x equals 9, whatever you call it, x equals 9, or you can say a equals 9, is given by so remember the formula. When x equals a, the formula is p2 x equals f of a plus f prime of a over factorial 1 x minus a plus f prime of double prime of a second derivative of a factorial 2 x minus a squared. So that is the formula for, for second degree polynomial. So square, second degree. So that is the formula I just copied from here. So because we're looking for a second degree, we can, you just copy up to x minus a squared. Now we want to substitute the value. Substituting values of, we get f of a, which is, let me write, because a is 9, so a is 9 plus f prime of 9 over factorial 1 x minus 9 plus f prime of 9 double prime of 9 factorial 2 x minus 9 squared. So, and then now I substitute the value, which is 3 plus this guy is 1 over 6 over factorial 1 is 1. So you'll get x minus 9 plus this guy is negative 1 over 108. And then factorial 2 is 1 over 2 and x minus 9 squared. So basically what we got is we got 3 plus 1 over 6 x minus 9 minus 1 over 216 x minus 9 squared. That's what we got. Okay, that is our polynomial. Any question so far? Okay, let me write this nicely. Our polynomial of degree 2 is equals to, I just want to bring it all the way here. Okay, so that is our polynomial of degree 1. Let's say this is equation 1. Now we are not done, so we need to approximate this value right here. Square root 9.3, we need to find that value. How do we do that? It's the same idea that we did earlier, okay? So first of all, we need to figure out what is the value of x. So to find the approximation, approximate value of square root, what is that? Square root 9.3, 9.3, which means 9.3 power half. This one. So set whatever the function given, which is square root x equals square root 9.3. Okay, whatever the function is given, you set that function equal to this, and this gives you x equals 9.3. So substitute this value in equation 1. Substituting x equals 9.3 in equation 1, we get 9.3, which is actually P2. This is 9.3 equals 3 plus 1 over 6, 9.3 minus 9, substitute the value of x, minus 1 over 216, 9.3 minus 9 square. and use your calculator and let me know what is your answer. And when I'm plugging in my calculator all these values, so my calculator is giving me 3.0496, and I want to verify that answer with you.
Yes, I got the same.
Okay, so now let us check what is the exact value of this by using calculator directly, not using this Taylor polynomial, okay? So we want to use calculator directly and see whether our answer is approximately correct or not. So by using calculator directly, calculator directly, so square root 9.3. Can you tell me how much is that? All right, so using calculator directly, that is what we got. Square root 9.3 is approximately the same thing, 3.0496. So it means square root x can be written as a polynomial in this form: 3 plus 1 over 6 x minus 9 minus 1 over 216 x minus 9 square. Okay. Okay, so the general Taylor series, here is the definition. Let f of x be a function that can be differentiated n times at x equals a. Then the Taylor series of f of x at x equals a is given by, oh, this one is actually the polynomial of degree n. But remember, when we don't have, earlier what we did is we stopped there, fn factorial n x minus a power n. So we stop there for polynomial of degree n. But when I say series, then it's an infinite series, and you don't write that term. It just goes up to infinity, okay? So this series is called the general Taylor series of f at a, or about a, or center at a. Okay, this is the, I'll write f of x here instead of p because we are talking about the series. So, okay, I'll write f of x. Now, later, Maclaurin is another mathematician. What he did is he substituted the value of a equal to 0, okay? So in all a equal to 0, and he came up with this special type of Taylor series, and we call it Maclaurin series. All right, so what is Maclaurin series is, if all derivative of a function f exists at 0, then the Taylor series of f at 0 is defined to be f of x equals f of 0, f prime of 0. So you just substitute a equals 0. And whatever series you get, that series is called Maclaurin series. So Maclaurin series actually is a Taylor series at 0. So it's a special kind of series, okay? Now let's look at example 4. Find the Taylor series at 0. Oh, by the way, anyway, so yeah, let's look at this. Let's work on that, and then we'll discuss about how to use these as a formula to find other different variation of the functions. Okay, so let me do part A. So given f of x equals e to the x. So to find the Taylor polynomial at 0, so here is the formula. So what we need to do is we need to find the derivative and so on. The derivative will be the same, and we need to find the it's pretty much the same. as we did earlier, Taylor polynomial. So f of 0 is e to the 0, which is 1. F prime of 0 is e to the 0, which is 1. All right, so we're going to find Taylor series at 0, or Maclaurin series. Taylor series at 0, or sometimes called Maclaurin series, is given by, let me just copy the formula. The formula is this: f of x equals f of 0 plus f prime of 0 over factorial 1 x plus f second derivative of 0 over factorial 2x square plus f third derivative of 0 over 3x cube, and so on. It's kind of repetition what we did earlier, guys, okay? So let us substitute the value. So f of x is e to the x. F of 0, we already know the value, which is 1, plus f prime of 0 is 1 over factorial 1 x. So that's going to give me x over factorial 1. And if I substitute that value, I'm going to get x squared over factorial 2 and x cubed over factorial 3. And it is a series, so I just write dot dot dot, okay? So it's an infinite series, so it goes up to infinitive. You just stop there. In the polynomial, so depending on what degree of polynomial we are interested to find, we'll write those terms. But since this is series, it will go infinitive. You know, you will never end up getting all the terms. So you just live like that. That's it, done. Any question, guys? All right, in the same way, all these part A, B, C are similar. So let me do part maybe C. Okay, let us do part C. It's very similar, but let's do it just for fun, okay? So in part C, given f of x equals ln 1 plus x. This is given. Now I want you to find the derivative. Find f prime of x, second derivative, at least go up to third derivative, and it should be okay. So the first derivative will be 1 over 1 plus x, which means 1 plus x power negative 1. So the second derivative will be negative 1 times 1 plus x power negative 2. Third derivative will be 2, 1 plus x power negative 3. Any question? You guys all know how to find the derivative, not a big deal there. Now we need to figure out what is f of 0 and f prime of 0 and f double prime of 0 and f the third derivative at 0. So let us calculate this. F of 0 is going to be ln 1 plus 0, which is ln 1. Ln 1, you know ln 1 is 0. F prime of 0. So that means 1 plus 0 power negative 1. So that's going to give me 1. Second derivative, minus 1, 1 plus 0, negative 2. That's going to give me negative 1. So this will be 2, 1 plus 0 power negative 3. That's going to give me 2. And let us find one more derivative just for fun, okay, guys? So let's find the another derivative, what we get. So that's going to give me negative 6, 1 plus x power negative 4. So let us find the value for fourth derivative at 0. So which will be negative 6, 1 plus 0 power negative 4. That's going to give me negative 6. And we know the formula. So Taylor series at 0 is given by, the formula is f of x equals f of 0 plus f prime of 0 factorial 1 x plus f double prime of 0 factorial 2x square plus third derivative of 0 factorial 3x cube plus fourth derivative at 0 and factorial 4 x power 4. It goes like that. Now substitute the value. Substituting values, what we get now is that my function is actually ln 1 plus x, this is f of x, equals f of 0 is 0 plus f prime of 0 is 1 over factorial 1 x plus this guy is negative 1 over factorial 2 means simply 2 x square plus this is 2 over factorial 3 is 6 x cube plus this guy is a negative 6 over factorial 4 means 24 x power 4, and it goes like that. This looks a little ugly. Let us simplify it. Okay, so we're gonna get here only x plus minus the second term will be x squared over 2, the third term will be x cubed over 3, fourth term will be x power 4 over 4. So it goes like that. This is called, I mean, this is, what I'm saying is ln 1 plus x, the logarithmic function, we convert it into polynomial function. So this ln 1 plus x is equivalent to this polynomial functions, okay? So we found the Taylor series for, well, this is series. Taylor series for ln 1 plus x is given by this. Any questions so far? All right. So I trust you guys, you can do this part B yourself. Just in case if you need, help, then you can look at my lecture note, okay, for the detailed solution there. And let's move example 5. That is the last problem that we'll be doing. Example 5. Let's look at part A. Find the Taylor series for the function defined as follows. So what is given here is that f of x is 2x e to the negative x. So one way of finding the Taylor series at 0, okay? So can you add this? Taylor series at 0. So one of the way is to find the first derivative, second derivative, third derivative, and so on. And then we exactly the same way that we did earlier. Now in that case, it's too much work. You see, the first one, we have to use the product rule. So we'll get two terms. And if we do the second derivative, we have to use the product term again for both of these two terms. We'll get maybe 4 terms, and it's getting bigger and bigger. So, but little trick here will help a lot. It will save a lot of your time. One way is to do this way, but I don't like that method because it takes a lot of time. And I know that you people are busy. You don't want to spend a lot of time for this if there is another nice method, right? So we're going to learn that nice method. So we already know e to the x equals 1 plus x squared over factorial 2 plus x cubed over factorial 3 plus x4 over factorial 4. We already know this. By the way, the interval of convergence is negative infinity to infinity, but this is called interval of convergence. Interval of convergence. But forget this idea, okay? Interval of convergence is actually the out of the scope of this course. Usually we do this in calculus 2 for science and engineering, but at this time, just leave it. Just focus here. Now, this is the formula we already know. Now, what is the difference here is that we need e to the negative x, not x. So replace x by negative x, so that it will give you e to the negative x. You replace every x by negative x, you're going to get 1 plus negative x squared over factorial 2 plus negative x cubed over factorial 3 plus negative x power 4 over factorial 4 plus like that. Now we are not done yet, so there is still 2x more. So what you do is multiply both sides by 2x. Multiply both sides by 2x. So we can do that, right? So if I multiply both sides by 2x, you're going to get 2x e to the negative x equals 2x, and then multiply everything there. So it's going to be 1 plus, 1. If you write this nicely, you'll get 1 minus x plus x over factorial 2 minus x cubed over factorial 3 plus x power 4 factorial 4. It goes like that. That's it. Okay, so in another word, 2x times e to the negative x can be written in that form, in terms of polynomial. If you think this looks a little ugly, then you can multiply it, no problem. So that's going to give you 2x minus 2x squared and plus 2x, oh, this is x squared, 2x cubed over factorial 2 minus 2x power 4 over factorial 3. Factorial 2 means 2. Factorial 3 means 6. Factorial 4 means 2x power 5 over factorial 4 means 24, and so on. Okay, that's it. If you think still this looks ugly, then you can go one step further and you can write x cubed minus x power 4 3 plus x power 5 12, and so on. Any question, guys? All right, last question. So I need 2 extra minutes, I think. So let's try part C just for fun. Very similar idea, but let's try that and we'll be done. Part C, the given function is negative 7 ln 1 plus 4x. All right, so again, one way is to find the derivative of this, okay? First order, second order, third order derivative, but we already learned the better technique, okay? So what we do is we already know ln 1 plus x equals, we already know this. I think we have already proved that this is x minus x squared over 2 plus x cubed over 3 minus x power 4 over 4 plus, I think this is what we proved here earlier. Look at this. This is what we proved. We can use this as a formula. Okay, I just copy that down here. And now when I compare this, the difference is 4x is there, not x. So what I want to do is replace x by 4x. So that you will get ln 1 plus x means 4x equals 4x minus 4x squared over 2 plus 4x cubed over 3 minus 4x power 4 over 4 plus it goes like that. Okay, we are not done yet. There is minus 7. So we multiply both sides by minus 7 and we'll be done. Multiply both sides by negative 7. So you're going to get negative 7 ln 1 plus 4x equals negative 7 times, you multiply everything by negative 7. So you're going to get 4x minus 16x squared over 2. That's going to be 8x squared plus this is 64 over 3x cubed plus this will be 64x power 4 over, not, okay, this one, I think you know how to calculate that, right? So it's simple calculation. You simply get, I believe, 64 there, x4 plus it goes like that, and you multiply. If you want, you can multiply this by negative 7 and write it down. So that will be the answer. If you have any question, let me know. Otherwise, I think we are done and we want to